Hello guys, welcome back to our YouTube channel. In the previous video, we dealt with trigonometric identities, and in this video I'm going to show you guys how to apply the trigonometric identities and some of the informations that we have gotten throughout this course to solve questions. Okay, we are going to be solving questions. So yeah, without much ado, let's start. So the first question I have today is, let me change my ink. The first question I have today is, if sine A is equal to square root of 3 over 2, and then A lies in what? The second quadrant, find cos A and tan A. So here, the most important information, just one of them is what? The second quadrant. Thus, they are trying to communicate to you the position of what? Or where the angle is located in the plane, okay, in the Cartesian plane, where the angle is located. So when you draw the plane, you know this is what? The first quadrant, second quadrant, third quadrant, and what? The fourth quadrant. So here directly they're telling you that what? Your angle is in what? The fourth what? The second quadrant. So we are now talking about what? The angle is probably somewhere here. Okay, that's what they're trying to say. So when you do that, and then what this should communicate to you is that what? In the second quadrant, the only sign is what? Positive. Cos is negative and what? Tan is also negative. So then the angles that you are finding here, like the ratios that you are finding, cos A and what? Tan A, both should be what? Negative, because we are talking about negatives now. Since like they are not positive in that quadrant. We are talking about that quadrant. So now let's go and sketch. Or let's not just sketch. So to solve this type of question, we can solve it using two methods. Okay, you can use the trigonometric identities method, and then you can also use the what? The normal method that I will show you guys later, where you use the Pythagoras theorem, you draw the triangle and stuff. Yeah, I'll show you that one. Now, without much ado, before we talk about using the trigonometric identities method, I would like us to recap on what we have. There's some of the trigonometric identities that we found in our previous video. So one of them is what? Sine squared, let me just use A, plus what? Cos squared A should be equal to 1. And then we have 1 plus what? Tan squared A is equal to what? Sec squared what? A, right? Then the third one is what? 1 plus cos squared A should be equal to what? Cosec squared A. And the fourth one is what? Tan A is equal to what? Sine of A over what? Cos of A, right? So in relation to this question, which of the trigonometric identities relates what? Cos and sine, right? So that's the type of question you should be asking when you are trying to use the trigonometric identity method to solve this type of question. So which of them? So you can see that the first one best relates what? Sine and cos in this context. So we are going to use that to solve the question. So using sine squared A plus what? Cos squared A to be equal to 1. And we know that what? Sine A is equal to what? Square root of 3 over 2, right? So now let's go. So we have what? Cos squared A to be equal to 1 minus what? Sine squared what? A. And this should be 1 minus what? Into bracket square root of 3 over 2 all squared. And this should give us 1 minus 3 over 4, which will give us 1 over 4, right? So this is equal to what? Cos squared A. So cos A will be equal to plus or minus square root of 1 over 4, which will give us plus or minus what? 0.5, right? So the answer we have now is what? Plus or minus 0.5. But then remember, we said what? In the second quadrant, cos is what? Negative. So the answer that you are supposed to get for cos A should be what? Negative. So you now say what? Since the angle in question is in the what? Second quadrant, I'll just use for Q for quadrant, comma, cos what? A will be equal to negative 0.5. So you need to justify why you selected the negative 0.5 over the positive 0.5. If you just stand up and say that your answer is negative 0.5, the examiner might what penalize you because you've not stated your premise why it should be 0.5, right? Now let's find out what tan what A is. Now to find tan A, you can use what the trigonometric identities, and the one that best will describe this is what the fourth one, right? So you know that tan A is equal to what sine A over what cos what A, and we know sine A to be equal to square root of 3 over 2, and then we know our cos A to be now 0. What negative 0.5. So when you solve this, you get what negative what square root of 3, right? So therefore our what cos A is equal to negative 0.4, and tan A is equal to negative square root of what 3. So yeah, so this is that. So this is just one method of solving it. Let me just get let's use what's the second method. So let me just write your second method of solving it. So we are given that what sine what A is equal to square root of 3 over 2, and that's what the angle lies in the what second quadrant, right? The angle lies in the second quadrant. So what you can do is actually sketch this out. So if you sketch the angle, so the angle is here A, right? And then we know that from so sine is opposite over what hypotenuse. So opposite over what hypotenuse. So the opposite is square root of 3, and the opposite here is this side, square root of 3, and the hypotenuse is what 2. The hypotenuse is 2, right? Now we need to find what the adjacent, right? Let me just represent the adjacent with what some x. So from Pythagoras theorem, uh, x will be equal to what plus or minus square root of what 2 squared minus what square root of 3 squared, right? So x will be plus or minus square root of 4 minus 3, which will give us plus or minus what 1. But then we know that x is on what the negative x-axis, right? We know this is the positive x, this is the negative side. So therefore x should be negative. So therefore x is what negative what 1. So when you redraw this nicely, you should get something like this. This angle here should be A, this side should be negative 1, 2, and square root of 3. So now we can now find for what cos what A. We know cos is what adjacent. Adjacent is what negative 1 over what or hypotenuse, which is 2. So you get negative 0.5. Then we can now find for what tan of what A. You know tan is what opposite. Opposite is what square root of 3, and the adjacent is negative 1, which will give us negative square root of 3, which is the same as the answers that we got using what the other method, right? Okay, so now let's move to our second question. This is also similar to like the first question. The only thing that's basically different is how they try to tell you the position of what the angle, where the angle is located. You see that this time they are telling you that an obtuse what angle, and if you are following this course from the beginning, you realize that we've talked about obtuse angles, where we said obtuse angles are 90 degrees less than what the angle less than what 180 degrees. In similar case, it's just mean that what the angle is between what 90 degrees and what 180 degrees. That's the same location for what the second quadrant, right? When you draw this one, we have, this is the first quadrant, 0 to 90. This is the second quadrant, 90 to what 180, right? So it means that's what the angle is, what somewhere here. So that's the same thing that they are trying to tell you. That's what the angle is in what the second quadrant. So everything you should be doing, you should be looking at what the second quadrant, where sine is positive, cos is negative, and tan is also what negative, right? So that's what you are going to be doing. So what should I use? What should I use? Should we use the, let's just use, what method should we use? What method should we use? Let's use the second method that we talked about. So let's draw the angle. Yeah, so we have talked about what two methods. So try your hands on them. The one that you like, you can master it and then what keep it. So we need to find what the adjacent here. So from Pythagoras theorem, you know that x is what plus or minus square root of what 17 squared minus what 18 squared. And when you do that with your calculator, you should get 15. But we know that what the x here is lying on what the negative x-axis, so x should be equal to what negative what 15, right? Now after finding that, you can redraw our triangle to look like this. And also when I'm drawing the triangle, I normally don't include the 90 degrees because I believe it to be like kind of complex, but there is 90 degrees. It's a right angle triangle. That's why we are applying what the Pythagoras theorem. If it's not a right angle triangle, you cannot be applying Pythagoras theorem to it. And this is negative 15. So now you can answer the same question. So what is what cos b? You know cos is what adjacent, right? Negative 15 over what hypotenuse 17. And we know now tan b will be equal to what opposite, which is 8 over what adjacent negative 15. So this is what you have, right? Now let's move to the third question. So they said if 180 degrees is less than 270 degrees and tan b is equal to 12 over 5, find sine b and what cos b. Same as the other ones, they are trying to hide where the angle is, right? This one is pretty clear, but you might get confused as to where it actually is. So you can just draw the plane. We know from 0 to 90, this is 180, this is what 270, and this is what 360, right? So with respect to this question, the angle is what lying in the what third quadrant. So 1, 2, 3, and 4. It's lying in what the third quadrant, where what tan is positive, cos is negative, sine is what negative, right? So that's basically what we'll be doing. So let's draw our Cartesian plane and the angle. So when you draw that, then this side is what b. There is always 90 inside. Okay. Then we know that two are right, opposite hypotenuse. So this is the opposite and this is the hypotenuse. So the opposite here is 12, and then the what adjacent, not hypotenuse, adjacent. Adjacent is 5. But then if you study this diagram carefully, you realize that the 5 here is standing on what the negative x-axis, right? So it means that it's a negative value, so it should be negative. And then the cos, the 12 here is also in a what negative y direction, so this one should also be what negative, right? It should also be negative. If so, the values over here all should be what negative. And the reason why it is positive here is because you are dividing negative over negative, and that should give us positive. So that's why it's positive. Now the next thing we need to do is to find the what hypotenuse h. So the hypotenuse will be equal to what square root of 12 squared plus what 5 squared, and that should give us what 13, right? The hypotenuse will give us 13. So when you do this, when you redraw, we have negative 5, negative 12, and here's 13. Now what is, oh, I forgot the b. So what is what sine b? Sine b is equal to what opposite? The opposite is negative 12, and the hypotenuse is what, 13, and cos B will be equal to what, adjacent -5 over what, hypotenuse, which is what, 13. So with that, we have gotten our what answer. You see how simple it is. So you need to like state some things, and then you can also use the trigonometric identity method. That one, so you should find it very easy to do. It's very simple. And then yeah, that's that. So the next thing we'll be doing is actually talking more about what, trigonometric what, identities. The one that we have talked about, we talk about only what, four, right? We talk about only four, which is the basic ones. But then we can have complex trigonometric identities, which they will ask you to what, reduce to simple form. So in the next video, we'll be talking about how to what, deal with reducing complex what, or simplifying what, complex trigonometric identities by using just the simple trigonometric identities. So see you in the next video. Don't forget to subscribe to our channel, like the video, and comment. If you have any question, just comment in the comment section, and then I'll get back to you.